Hello everyone, today we're going to talk about the identification of soybean salinity tolerance use 3D reconstruction model. This is our group member Yulin, Yiwei, Chang, and Jing, Zhou. This is the introduction of our project. This is the working flow of our project. First, we collect the image, and then we reconstruct the 3D model, and after that, we calibrate and correct them. Calibrate and correct the color, and then we segment the background. After that, we detect the plant sample and then separate them. And finally, we analyze and identify the results. After collecting all the image, we put all the image and camera position, the markers into this software called EdgeSoft. It's based on the structure from motion, and after that we can get the 3D points cloud. And this is how we get the 3D reconstruction result. Then we segment the background. The color threshold was applied to remove background from plant's dense cloud, according to histogram of different color channel. Green channel from RGB and a channel from LAB have distinguishable feature for background and plants. This is the result after green channel. This is the result after A channel. This is the part of color calibration and correction. Due to the light change during the filming, the color of picture will deviate. We use the curve fitting technique to rescale the RGB value and use color checker as the standard to correct the color of point cloud. We use black, blue, red, and orange for color correction. To get better result, we turn the original RGB image to HSV image. After driving the curve fitting function of SMV, we put point cloud data as input and get a correct HSV value and turn it back to RGB value for compute. And this is the comparison between the original graph and the graph after processing. And for the plant sample detection, basically we use K-mean to separate the plants. Because there are lots of plants in the 3D model, so we separate all of plant to 26 plant sets, and for each set, it has 15 plants, and to get the volume of each plant, we use K-mean algorithm to separate the plants. And this is the step of how we use the K-mean. This is the result after we use the normal K-mean to process the graph. And as we can see, this is not the result what we want because some of plants were separated into two parts, and some plants even be separated into three parts. And so we need to change some strategy to use this algorithm. And this is the change we made to our program. We use in the step 1, we use the estimate center point instead of randomly generating center point, so that if the program using this point to clustering, it will be faster and more accurate. And for step 2, step 3, and step 4, basically we just did what we used to do. This is the result of a single plant after processing. This is the result of a set of plants. We change the color of every plant to make people see it clearly. This is the GIF of our result. and our future work is to analyze this and identify the result after the image processing. Thank you.